All right, here we go, guys. We are going to fire it up this week and learn what it means to have the standard form of a linear equation. So you guys can turn to page 46 in your workbooks and follow along with these examples. And I think that will be the very, very best way for you to have in your notes kind of how to handle the standard form. So it looks like this if a linear equation is in standard form. It looks like a number, ax, plus, and then a number, by, is equal to a number. So this is called standard form. And I want to show you guys how you can graph in standard form. You also can convert standard form to slope-intercept form if that's an easier way for you to graph. So we want to be able to apply this idea of working with an equation in standard form for your linear equation. So that's our target for this week. So let's go ahead and try one. And what you see is on these questions that we're doing for our examples that you have, in this case, I'm just going to write it over here to the left. It's actually 1x, there's an understood 1 right there, plus 2y is equal to 8. Okay, so just a reminder, if we're finding the x-intercept, then 0 is going to be our y value. And if we're finding the y-intercept, then 0 is going to be our x value. So basically what we're doing is we're trying to figure out where the graph crosses the x-axis and where the graph crosses the y-axis by doing a substitution. So I'm going to go ahead and show you how that looks. So let's try it here. First, we're going to substitute. Let's do this one first. First, we're going to substitute a 0 in for y so that we can figure out what x is going to be. So there the 0 goes in for y. And that means that 1x plus 0 is equal to 8, which just means x is equal to 8. So that is our first coordinate point. 8, 0. I think it's right there. 1, 2, 3, 4, 5, 6, 7, 8. Then the next thing we're going to do is we're going to substitute a 0 in for x and solve for a corresponding y. So let's try that. 1 times 0 plus 2y is equal to 8. Oh, we're getting so close here to being right on top of this. 2y equals 8, and if we divide by 2, we get y is equal to 4. So those are my x and my y-intercepts, so I'll go to 1, 2, 3, 4 and put a dot right there. And it says find the x and the y-intercepts and then graph the line. So then what we need to do is we just need to draw the line that is going to go, whoops, if I can do this carefully, a little tricky on the screen as you guys know, through those 2 points, just like that. Your guys' probably turned out a little bit better than mine. That's okay. All right, what I'd like you to do right now is if you want to just take a minute, you can pause this video, right, and try number 2 on your own. So maybe if you pause the video and you tried number 2 on your own, maybe you're back now, hopefully, and we're going to just kind of go after this in the same way. For our x-intercept, that means we're going to plug a 0 in for y, so let's try that. 3 times x minus a 0 in for y equals 9. We get 3x equals 9. And as we divide both sides by 3, we get x is equal to 3. So that's our x-intercept, and we can plot it. 1, 2, 3, right there. Okay, then we're going to get our y-intercept, which means we're plugging a 0 in for x. So here we go. We're going to grab our equation. We're going to say 3 times a 0 for x minus y is equal to 9, which means 0 minus y equals 9. That's a little tricky because it's actually a -1 that's being multiplied times y right there. Oh, I changed my 9 into a g. Let's change it back to a 9. There we go. And as we divide by -1, we get y is equal to a -9. Don't forget, guys, when you take a positive number and divide it by a negative number, you're always going to have a negative result. So let's see if we can find -9 on this. I don't know if I can, maybe if I blow it up. 7, 8, there it is, right there. I'm going to do a little zoom in so I can make this line a little bit nicer. And there we go. We'll zoom back out. So hopefully that example, when you guys kind of took a look at the work that you did, hopefully what you were seeing is you were trying something sort of like this, where you're keeping your work organized, first making y equal to 0 to find x, and then making x equal to 0 to find y, and solving and graphing from there. Okay. Question number 3, 4, and then 5 and 6, which are below these on your worksheet, are part of your assignment this week. Okay? So maybe we'll work on this in class a little bit. Should definitely try a couple on your own prior to getting to class. And then what we're going to also be working on in class, today we're going to kind of scroll up here a little bit, still thinking about the standard form of the equation. So we're still thinking about this ax plus by is equal to c, our total. And I want to show you an example of how you can use standard form to solve an applied problem like this one. Okay, so let's take a quick peek at this problem and do this one together, and then you guys will be on your way and rolling through the week. Okay, standard form. There are elves and reindeer in Santa's barn. Okay, so for this example, we are making an assumption that all the elves are going to have 2 legs. Okay, and we're also making the assumption that our reindeer are each going to have 4 legs. Okay. So there have not been any tragic accidents that have left any of our elves or reindeer with any fewer than 2 or 4 legs, respectively. Okay, that being said, let me show you how we're going to set this up. It says there are 40 legs in all. Oh my goodness. Okay, 40 legs in all. And there are elves and reindeer in Santa's barn, 40 legs in all. And it looks like we are going to have to figure out the possibilities for number of elves. Let's assign that an x variable. And number of reindeer. It's always important when you're working on applied problems that you assign your variables to mean something, right? So you know what you're actually looking at here. And we know that there are 40 legs total. So it's good in standard form to have a total that you know. So we know we have 40 legs all together. Okay. So what that means then is we are going to have to put together the number of elf legs and the number of reindeer legs to get 40 legs total, right? We're going to use this information to make this happen. So here we go. Let's take 2 times the number of elves. Basically, that's 2 legs for each elf, plus 4 legs for each reindeer. Y is my number of reindeer, and that's going to equal a total of 40 legs. All right, That looks like that could be 40 legs, like altogether. I think that's looking pretty good. It says, what is the x-intercept and what does it represent in context? What is the y-intercept and what does it represent in the context of this problem? All right, so we talked about how to solve for this just a minute ago. If I want the x-intercept, I'm going to have to plug a what in for y? Yeah, 0. You got it. Okay. So it looks like 2x equals 40 and x is equal to 20. Now what this means when I graph the point 20, 0, what it means for the problem is that I have 20 elves hanging out and no reindeer, right? That's what I'm looking at here with this point. So let's go ahead and graph it. Wow, 1, 2, 3, 4, 5, 6, 7. You guys will have to help me out. Let's just say this is the point 20, 0. Okay. Apologies if the counting isn't exactly right. Okay. And as we continue, we're going to find the y-intercept by plugging a 0 in for x. So here we have plus 4y is equal to 40. 2 times 0 is 0, so we have 4y equals 40. And if we divide by 4, right, we're going to divide both sides by 4, we get y is equal to 10. So 0, 10 is another point on our graph. What does this mean in context? This means that we would have no elves, right? That would be a situation where there were no elves and there were 10 reindeer. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll put 10 about here. Okay, and that is the point 0, 10. All right. And the y side of our graph represents reindeer. And the x part of our graph represents number of elves. Okay, so you always want to be aware of what you are plotting and what it means. And then what we can do is we can actually draw the line, and again I'm going to zoom in on this a little bit and try and draw my line sort of straight between the x-intercept at 20 and the y-intercept at 10. Zoomed in, we're going to zoom back out, and that is an example of applying the standard form of the equation. All right, guys, have an awesome week. I will see you in class. Take care.